Hello. Let's take a look at what we are going to study this time. Last time we looked at all the basic screens of an app and how to make sure that several of the nuances of user interfaces and the database interaction turn out to be right. This time, what we are going to study is an aspect of web applications which simply does not exist anywhere else. This is the fact that in all applications, or in all web applications in particular, we actually can share links to web pages. So something interesting happens. Imagine, for instance, that I press a report button here. As you will notice, I have changed the appearance so that there is a new tag at the end of this page. And the reason I do this is because eventually we want to be able to do something like this. So let's say 2024 04 and 22, suppose. When I send this URL, assuming it's a shareable site to other people, they should be able to see exactly what I'm seeing. So this is one of the sort of superpowers that web applications have, which is that you can actually, as you execute the application and as the application goes through stage by stage, a reference can actually exist to each of those stages that you can share with other people. And there's more to it than just sharing. So for example, yes, we can share it, but also we can cache the contents locally so that you can move back and forth. For example, if we have one of our standard database application, and let's say I register a bunch of users. So let's say U1, then I register U2, then I register U3, and so on. As we saw in the history, all of these pages are actually still available. So if I go backwards, right, I am actually seeing the older users and their pages. In this app, because I use a single URL as I just highlighted, we cannot actually share these independent screens. Now, there are several questions here. Since we can share screens, one question is, which part of our application should be shareable, right? It's not as if you necessarily want everything to be shared. If, for example, you are entering your credit card data, let's say, in some app, you really don't want a situation where even by mistake you happen to cut and paste that URL, and then you send it to somebody by mistake and now they have access to your credit card. So not all states should be shareable, first of all. And on the other hand, we do want some states to be absolutely shareable. There are two extremes. In an app that involves credit cards and such things, we probably want sharing to be an absolute minimum. Perhaps you might share it amongst you and your spouse or somebody like that. On the other hand, you have a document website, right, which is just a document, in which case you just want to share it possibly as widely as possible. So the extremes are something like a bank versus something like Wikipedia. But in most cases, you want something in between. For instance, if you have an e-commerce site, let's say, then you might want to put some items in your cart and then come back to it 6 months from now. 6 months is a bit too much, but let's say 3 days from now. And you should still be able to see what is in the cart, even though you have logged out of the browser completely, right? You should be able to recover that. And as we all know, at least Amazon for sure does this. I've never kept anything that long in Flipkart, so I don't know. But I assume they do. There is no particular reason. So in this case, you are not sharing with other people, except perhaps with friends or whoever you might care about. But you are sharing it with yourselves 3 days from now, let's say, right? But this ability is still there, that you are able to take a snapshot of your interaction and share it. Prior to the web, such a thing simply did not exist. It is quite magical and it is quite strange, and it is an unusual thing to have to think about in application design. So caching happens, bookmarking happens, and the other thing that you see in a web app, which was quite novel, no GUI app prior to the web ever had anything like the ubiquitous back button. And one of the more surprising studies showed that the back button is probably the most used button on a browser, and it's very popular, and people don't like it when they cannot use the back button. Typically, you will see in banking sites and such that they will either prevent you from using the back button, or they will somehow tell you that if you press the back button, bad things will happen. So thinking about the back button is an important part. And related to this, two other things come up, which is how to design this shared application state, and something else that comes up related to that, which is called the post redirect get pattern, which is one of those things that arises out of this interaction of, should I cache this or not? Should I bookmark this or not? Should this application state be visible or not? And if it is visible, how to make it visible? Plus, the thing that we don't normally notice, right? If you allow going back and forth amongst forms, one of the things that can happen is, because this form is an active part of my application, I may accidentally, either I can do, for example, refresh, in which case a browser will give you a message like this. For a programmer, this might make some sense. But for a normal user, this doesn't make much sense, and they might just hit resend. And then, of course, this happens, which is okay, because all things said and done, it's not as if you are allowed to the error is going to cost us anything. But then you find sites which will allow only 3 login attempts and things like that for security. So that can also be an issue. And then even if I normally hit a register button, again I get the same error, but this time at least the input is cleaned out so that I have to write something new. And then, as you can see, as soon as you did that, this forward button disappeared. But we are still here. I can, if I go back there, again the forward button in this case disappears. So the future, if you are in the middle of some kind of back and forth thing, the future can be pruned away, but the back button is still there, and quite a few of the old states are still available, right? So it's understanding the interaction of these things that is our goal during this part of the session. Let's see what's next. So, okay. Now, these are some of the things I have mentioned already. One is URLs allow you to share references to screens. They can be cached, which leads to these kinds of questions. They can be bookmarked, and they can get out of date, by the way. They can be refreshed. They can be shared with one another. And sometimes you want the sharing, at other times you don't want the sharing. For example, on Google Docs, you can get a so-called shareable link. So a shareable link by definition makes your document shareable. And think about what is needed for sharing to work. Some person gets this link and comes in. Now Google has to say that, am I supposed to show it to this person or not? So if it's a specially crafted thing where the permission has been granted by the creator, then by all means, right? But it can do more than that. It can share just among people who have the link. It can share widely. It can share within an organization. It can, I don't know if it can share within a specific group within an organization or not, but certainly you can designate specific people. So sharing can be controlled at a varying grain. And then these kinds of things, so universal back button, it's so far so good, but there are a couple other things that also show up in this list. One is front-end actions can be interrupted by network effects. Now here, if I hit register, right, if I go here and to the last one and hit register, because it's on the local host, it generally won't get interrupted. But if this was on a mobile, it could get interrupted or even silently dropped, or there could be a bug in the browser. Any number of things could have happened. The other thing can also happen, which is the front end actually succeeds in contacting the backend, but then the backend effect occurs, but the front end is not refreshed. So quite unusual states about an application can arise because of this kind of sharing as well as because of network effects. So let's study what is needed to deal with this entire list. Okay, I'll leave it here for a minute so you can pause this thing and take a look at the list and think about it. Okay. Now that we know that using URLs, you can share application state in these different ways, let us see how it is that a URL actually refers to the state of an application. So here is a list. Here are some variations. Let's say we are visiting this application for the first time, right? Here what has happened, let's begin from the manager. So here what has happened is we just visited this application, and to show you that it was a get, let me just go in here and refresh that, right? So this is a get, and a get gives us a form. At this time, if we had a login type functionality, then there would be some context which says done by means of a cookie, and we will see the details shortly, how to identify that you are logged in. In fact, if you are visiting the login page, there's nothing, no cookie yet, right? And that's what we have. Now, going back and forth, let's try and register a few users. Let's say we have D1, then D2, then we will put maybe some expense in here, or let's put a user. Here we have D3, then you have D3 10, and I'm going to hit expense. Then I have, D2 22, something like that, an expense, and now I will register a D4 as a user. So in doing all this, we have built quite a bit of browser history here in the back button. And all of these things that we have seen so far were post methods. And if you look at what the post does, it has a bunch of these things. By the way, notice there is a cookie in this. This cookie is not ours. It is from the Tomcat manager. We will talk about our cookie, meaning the cookie for our application in a little while. Okay, so we have built together a list of these kinds of activities. And if you go back now, see, the only get request it makes is for the fav icon, right? It does not make any other get request. If I go back, again, there is a get request for the fav icon, get request for the fav icon, etc. If I go forward, it's basically the same thing. So what this means is the browser is not visiting the database at all when I just go back and forth. All I'm doing is I have a memory of all the pages that I have seen, and then I can go back and forth among them. This is the page we are at. This is the future. This is the past. That's where we are. But the first time we went ahead though, we were doing some action. So which means we were talking to the database and getting some results back. When going back and forward, we just use the cache URL as we saw. If you revisit after some time, now in our case, we aren't using cookies or anything, but things can happen. For example, the cookie may have expired. If you bookmark and revisit, the cookie may have expired or it may be deleted. As we know, a cookie is as I have mentioned before, a cookie is something the browser remembers just in order to identify the request and to connect them with each other. And if you share it by sending the URL to someone, the incoming person has no cookie. In fact, there is no context at all other than what is in the URL. So in other words, the context and what you see depends on when you visit, how you visit, what type of data it is, and so forth. there is no requirement that a browser should have a cache. It could be that the browser always visits the database in order to get the state. And in that case, going backwards is a little strange because you cannot undo what the application has done. So there is a strange sort of disconnect. Okay, you have to think a bit about this. When going forward, we talk to the database, we make changes, and you show the next screen. But going backward doesn't mean you are undoing it. You are merely looking at the picture you had before you did the submission. So that's crucial. It's just an image. Let's say that out with a specific example. Every screen represents a shareable state of an application. In the case of e-commerce, it might be putting items in a cart, add a payment, add addresses, then submit. When you move back and forth, the screens contact various services, and moving among screens can invoke actions. But not all the back and forths can be meaningful because you cannot undo, say, a payment, right? So it is not as if you are rewinding time. Only that part which is under the control of the browser can be rewound. This, as you can imagine, is problematic because suppose you have completed a credit card payment, then you go back, and if the credit card data is still there, then going forward we'll do a second purchase, which is definitely not what you want. While going back will not undo the purchase you have already made. So what has happened is you have created a disconnect between the state of the database on one side and the thing you can see on the screen on the other side. And this is what we need to resolve properly in our application. Okay. So the takeaway here is moving among screens, especially forward, invokes actions, and moving backward cannot just undo the actions. Such a thing is simply not possible. Right. So the next stage is, since these kinds of time related effects arise, you cannot purchase a ticket twice, sites limit the number of tries. So what we have is you cannot always repeat actions and you cannot undo them. And so you have to take that into account when designing the application. So here is our situation. We know that moving forward in the browser by doing submits, using submits causes actions. Moving backward cannot physically undo a purchase. Then just a browser refresh cannot physically refresh a purchase. And moving forward, just the pages, just moving forward using just the back forward button, forward using just back forward button should not and cannot, of course, do anything about the physical action, about the purchase, right? So purchase, I'm using this as a kind of metaphor for real life changes that merely moving around in a browser should not have any connection. So if that's the case, and if there is a disconnect between the browser and real life unreversible activities, then what should we do? Our two options are completely disallow such a thing. To a degree, it can make sense. A cleverer design allows it, but recreates the before purchase pages in a way that makes it very, very clear that whatever else you do on the page, the best that will happen is you will in effect go forward. Now, This second option is much harder to do, and creating a full example for that is quite tricky. So I'm just going to point out that if you use your imagination based on some of the things that I will show you, you might be able, we will briefly discuss how you could allow or how you could create option 2. But in practice, we are just going to study how to disallow such a backward forward action. And secondly, how to, a sub bullet of this is how to live with multiple submissions, right? We already know how to live with them in principle, which is, if your backend is capable of detecting things like multiple registers, then in some sense there is no harm in the user accidentally pushing these buttons. Whether to allow that or not, again, is a fairly delicate design question, which you have to play with in the context of your app to see what that is supposed to mean. These are the other difficulties, that normally a user will just pass through in one direction and finish whatever work they are doing. But only in rare cases will they actually, do something like moving backwards and forwards. And so even you are not, it's not easy even for a developer to actually think of these cases. So that's one reason why I'm emphasizing this part of the material, that you have to have this mental model where real life actions have happened, the browser is showing something, and coordinating between the two is an important design issue. All right. Now, we already know what a cached version of this looks like app, right? We just go backwards and forwards. Let's take a look at what a non-cached version looks like. What does the user experience when we have a non-caching version of this system? So here I have a new version called FairShare NC, and I'm going to start this. So we'll take a look at what the network requests do, and we'll do much the same thing that I have done before, that I will create a few users. So let's say F1, then F2, then maybe F200 as an expense, then maybe create a user F3, and then let's try to create F3 who purchases something as 11 and then asks for a report. So we have built a history over here. Okay. But now watch what has happened when we do the, when we did all these post requests. Here is what has happened. So we did a post, and in the post, what we see is, let's first look at the body that we posted. So here we posted this body, right? Our last button pressed was a report button. Doesn't matter, all the button presses, as we know, look similar. And here are the normal headers. Okay. Then let's take a look at what happened, what we got back from the system. What we got back, which is different from the headers you have seen before, is 3 different new headers. One was this pragma, which is a header that says no cache. Then you have something interesting here. You have a new header called expires. For comparison, let me show you, So here you have expires, and here you have cache control. Now for comparison, let me show you the header over here. It was a post, but in the response header, all it says is content length, content type, date, and server. Whereas for this case, we have added cache control, expires, and pragma no cache. These are the 3 new headers we added. By doing this, we are telling the browser that it should not cache previous pages. And now if you go back, here is what happens. It says document is expired. It is no longer available. And then it will say that as a security precaution, Firefox will not automatically re-request sensitive documents. Click try again. Again, this time if the user tries this, right, you need other mechanisms to stop them from going forwards or going ahead and pressing this button again. But let's see what happens if the user uh, tries to just say, okay, something went wrong, I'm just going to go to the page where I was, and it goes one page forward. Oops, right? Even the forward document is now expired. So you are stuck. If you keep going backwards, you keep getting document expired. You keep going forwards, you keep getting document expired. This, although it's the effect you want, it is quite a horrible experience. And you may remember that some bank sites behave this way. And if you get stuck, really the only choice is they will have, some sort of messaging, or they will control the back button using JavaScript and other things, so that they tell you that, what, you just have to log in. This is the browser's default behavior, and you need JavaScript and a few other things if you need to control what happens when the back button is used. So although avoiding caching is certainly possible and something we should do, it is also the case that the user's experience here is not that great. So preventing caching can be necessary, but it can lead to bad experience. As in general, we should try our best to minimize this kind of experience on part of the user. So before we go ahead, let us see how it is that you implement this kind of cache control. So here we are. Let's look at our non-caching version of the system. Okay, here is what you have to do. The headers we saw are these three headers. Cache control, which says no cache, no store, must revalidate. Why so many headers? There are various reasons, but largely it has to do with history, how the discussions went, and what the designers wanted the meaning of these things to be versus what the community was already doing, different browser makers doing different things, and so forth. So this part of the header is needed for HTTP 1.1. This thing is needed for HTTP 1.0. Rarely needed nowadays, but still. And the header which says that the expiration date is 0, that is, the expiration date is 1970. Remember, time in this world begins in 1970. This is needed for intermediate components called proxies. We are not going to say too much about proxies in this course, just enough to know that they exist. And as far as Java is concerned, the code that sets these things looks like this. So you set a header to cache control and pragma, and there's something else called date header, which has a expire score. And when that is received, you get this sort of user experience. Just to see this thing again, let us hit register, and we will see that cache control and expires and pragma, these headers have been added to the response. So that's as far as the programming is concerned, and the rest of the code remains the same. The question that remains for us is, can we actually get smooth back and forth motion but with no resubmission of forms? And if so, we must be able to recreate screens without ability to resubmit, or we must be okay with resubmission that happens because you are detecting duplicates or something like that. And you can achieve this effect with a mix of server and browser interaction. Two ideas are needed here: post redirect get pattern, submission tokens to detect multiple submits. Once these two ideas are in place, we will be able to get the flow to be as smooth as we want. Doesn't mean you always want to allow arbitrary backtracking, but if you do, the things you learn will show you how to actually do it. Let us first study post redirect get, which among other things will tell us the need for addressable URLs. Addressable as in URLs that you can share with people that have adequate context, so that if you just type in the URL, the application knows what to do, even if you don't have a cookie, for instance. And then the next step after that is to examine resubmission tokens. And resubmission tokens is something we will talk about after we are done with cookies, because they are part of the same set of ideas. So for now, we will study addressable URLs and the post redirect get pattern.